Only so many, right? Thank you, Rodney. So, ladies and gentlemen, welcome to after lunch session. And you've come here not to sleep, okay? Because I carry chalks, I'm going to throw them on me. Be careful.
Carry what?
Chalks. The chalk.
Chalks?
Yeah, you write on the board, the blackboard, chalk.
Chalk.
Sorry. My English is Indian, Canadian, whatever you may call it.
It's just whatever it is,
Yeah.
Just go with.
It's just go with easy, yeah. So Rodney has 35 years of industry experience, including plant maintenance, engineering, manufacturing, R&D, and product design. Products include gaskets, packing, valves, injectable packing, and lubricants of all types. Rodney's work has involved production engineering at the factory level, as well as field services and technical sales. Rodney has had heavy involvement in refining chemical facilities. Heavy. Okay. Additionally, Rodney has had detailed focus over the past 15 years in environmental compliance and the advancement of environmental control products of all types, with an emphasis on consent decree compliance regarding fugitive emission control and low-E product development and solutions of all types. So if you would say, please welcome Rodney. Thank you.
Okay, so the way this is gonna, you might have read this as the 3 pillars of compliance. What I was asked to do was to identify what we consider the 3 pillars of compliance, but then I'm gonna put a heavy focus on pillar number 2 because there's been a huge move recently from the EPA down, including end users, valve manufacturers, so Mr. Bradley, to add a lot of compliance around the use of drilling tap that's been around for a long, long time. So if you look at what's driving this and why we're going to focus on this, there's been recent addendums that have been added to previously lodged consent decrees that have now brought forward the use of injectable packing as being equal to the traditional methodology of repacking valves with the diaphragm or braided product. And with that, they already were having to do the drill and tap. It was already identified in their consent decree or in their LDR program that most of them have words that like drill once, inject twice. Very common language in LDR programs and consent decrees. What was happening is those were just a short-term fix that was going on in the 5 to 15-day process that if before they could go to the DOR, that attempt had to be made. So when they walked away, they still had to come back and repair that valve at some point in the future at a turnaround or at some squat outage or whatever. They were going to have to do some form of repair. Now with these types of language, if they inject it with a quote unquote certified low-leak technology injectable packing, they get the exact same compliance as if they had shut it down and repacked it. So the EPA is accepting the use of these packings as if a valve isn't low-E, for example, a valve could have been installed before low-E packing was required in API 600. I'm not going to dive too far into that. But if someone then came in and injected it with a certified low-leak technology injectable packing, that valve can now be tagged and maintained as a low-leak valve going. The latest products meet the definition are the definitions that have been created and which has led to the potential of, well, not potential, it was potential, it's now factual. Several valve manufacturers have been approached by end users, and these end users have said, can you make these valves ready to go for injection as a new product? Now, that doesn't necessarily mean that it has this fitting on it. It could be a boss. It could be a treasure map X marks the spot. It could be a fitting. But here's the reason why. Majority in the beyond one past, majority obviously, the largest part of failures in drill and taps are because of the misplacement of the thing. because many technicians either don't follow exact guidelines for measuring and identifying that location, or the valve manufacturer has some kind of a burning stuffing box design where the packing is in a different spot than they might have realized it's in, which leads to them drilling into a spot that's not going to lead to an effective seal. So the end users now feel if they could get the manufacturers, the ones of the world, Rodney Forges, the kits of the world, that the valves are using to either position that fitting or identify the location of that fitting, then the technician does, that's one step that the technician can wipe off of his requirement is to try and identify where do I drill. Plus, we know we would have no wall thickness, we're not gonna have premature drill through, it's gonna lead to an uncontained leak at some point because someone didn't follow the guidelines correctly or effectively. So, there you go. These products get, hey, Mr. Frank, how you doing, man? Thanks for joining. Ultimately, what we're trying to do is we're trying to, when we developed this product, the low E injectable product, we were addressing a need for something that had been around for a very long time. So the drill and tap process goes back way more than 50 years. The process was really started being done on a daily, well, let's just say a daily basis in like 1961. And it's just become more and more common to the point that it is in the best practices guide. It was awesome. For the EPA, and every company pretty much addresses it in one way or the other. The industry drivers for the drill and tap, the LDR proven language, the consent decree language, it's considered a best practice by the EPA, the state agencies, they have requirements for it. You want to prevent product loss to the atmosphere, harm to employees, and got a really severe steam leak, they're drilling tapping those as well, and it prevents damage to the equipment. Here's an example of the consent decree language I was talking about. The drill and tap, except otherwise provided, so forth and so on. Another repair attempts have failed to reduce emissions below the applicable definition. The defendant is not able to remove the leak from the service. They shall attempt at least one drill and with a second injection. I don't personally like this language because we don't want them using a sealant, and I'll explain that to you here in a little bit, but we want them to, they have to eject, we want them using a packing, not something that will actually cure and could destroy the valve. Current requirements based on the EPA LDR guide, here they are. Repair the components as soon as practicable. First attempt repair include or not limited to what you see there, tightening the bolts, replacing clamp nuts, injecting a lubricant into a lubricated packing. That's the drill and tap language they use. Now, if you go back many years, long enough that I can remember, there may be some other people can, asbestos packing used to be the preeminent packing was used in all these valves. Well, every valve that came out had a grease fitting in the stuffing box area that the valves wouldn't hardly turn unless the guy came along and pumped some grease in there, because the asbestos was so hard and so dry, they would literally pump them before they moved the handle. Now we remove those grease fittings in the downstream sector, but we still have them in the midstream sector in the 60 valve or valve, stuff like that. They still utilize those fittings today for that. Additional LDR guide language. I'll just read the note. The drill and tap method for repairing leaking valves is generally considered technically feasible without requiring a process unit shutdown and should be tried if the first attempt at repair does not fix the leaking valve. That's just an important thing to understand there. And now they're allowing them to take credit for the repair, not have to shut down, not have to replace the valve. So it's a big advantage to use the drill and tap process. And I'm not going to go through every one of these one by one. Just take a look at the LDR guide. You'll see. Develop a plan, monitor the components daily over several days, replace the problem components with leakless or other technologies. This goes back to, I believe, 2008. So it could be updated today and take that language out now that they accept. Only thing I will point out that's a really unfortunate thing about this language is it says a drill and tap repair method where a hole is drilled into the valve packing gland and tapped. So just go ahead and note this right now. That is incorrect. You do not drill into the gland. Okay. Into the wall of the stepping box, the gland is what pushes the packing and makes the packing seal when you load it. There's a gland flange, there's a gland, and those two work together to compress the packing. This is what we don't want technicians to do, drilling in the wrong spot. Because if they drill into the correct gland, they're just going to pump injectables to the atmosphere and nothing's going to happen. So most companies do consider this. Got a question? Good? Good?
We're good. Yeah.
The advantage, continued operation of valve. Does everybody understand the process, the drill and tap process, or have seen it? Has everybody seen it at some point or understood it? It's done without a shutdown. That's the key factor here. That's why it's used so widely is because the unit does not have to take any reduction in pressure in order for the repair or the leak to be done. Yeah, which guy?
How do you feel about putting it out?
I love it. I think every injection port should have some form of an OEL closure, either a pipe plug or a cap, depending on the fitting type. So we'll talk about some of that here in a minute, but there's multiple ways to do it, and that's becoming a bigger question because of OELs.
That's right.
Yeah,
It's in your perspective.
If you read really efficient procedures for doing a drill and tap, it says inject, close the valve, remove the injection gun, and install a plug or cap on the fitting before walking with. That's what should be done. And then when the guy comes back, because you can do these, you can inject these time and time and time again by just coming in and cleaning them out and just pull the plug. And I mean, yes, it should be done. Just to show that there are, these are done with standards in mind, whether it's 1634. So without going into huge detail, 1634 is a valve design specification from ASE. If you think about API, they have all the standards that you guys may hear. You may hear API 600, 602, 603, 623. There's 7 downstream. There's actually 8, but there's 7 that matter as far as monitoring goes. We don't monitor check valves unless they're an emergency shutoff style. But there are 7 standards that have an emission test of some sort attached to them, whether it be 624 or 641. Those are all strongly based off the use of 1634 pressure guidelines and stuff like that. Boiler pressure vessel code, section 8, section 1, the 31.1, 31.3. And then there are some power industry standards that will follow as well on these repairs. Because drill and tap is just one of the on-stream repair methodologies that people use. Because if you can't use a drill and tap and you've got a supercritical valve and you don't want to shut down, come on in. Sorry, how are you? But the people will put an enclosure around the whole valve. They'll put a box, literally what they call a box. They'll just close the whole thing so that they can stop a HF leak or whatever they're doing. The process, I'm going to show this to you guys because I like for people to understand that, you know, how the process works. There is a measuring process, understand wall thickness. There is equipment to keep the leaks from happening. There is equipment to keep people from gassing someone when they're doing this, as you'll see. There is a proper location. The absolute perfect location is between the 3rd and 4th ring of packing. If someone knows how to measure and has worked with the valve manufacturer properly, that's an easy number to get to based on compression numbers. But that's why we want the valve manufacturers involved, because we're going to take that guesswork out of, did that packing compress 20% or did it compress 27% or did it compress 30 or did it compress 15? If Bonnie Forge or Bland puts a spot and says, when our valves leave our factory loaded properly, this is where you're going to drill, you know it's going to be between the 3rd and 4th ring. and it's gonna work like it's supposed to work. Sequences to tell them, you know, we give them this cheat sheet, right? Based on wall thickness, what they have to do. If they're at 275, if they're below 275, we're gonna recommend they walk away. There's not every valve's a candidate, right? I mean, there are safety factors that have to go into this too. So this is not the end all be all and fix everything, but if done properly, it's the right thing. And it can be an amazing resource. But these guys have to know that if they're at a 1/4 inch wall, there's something, there are ways to do it, but it takes an additional piece of equipment. It's not going to be here. There are some external devices you can use for the drilling taps for wall thicknesses that are less than these recommended numbers here. Drill stops, well, important, right? You don't want a guy just drilling and breaking through before he has a containment device there. And second, you don't want a guy drilling through and drilling into the stem, which has happened. I mean, actually, there's been cases where guys have drilled up the backside of a valve. I mean, these guys just, they think they're Superman and with X-ray vision, and they can just go up there and know exactly what to do. We put, there's the fail safes in place, and a drill stop's a huge part of that, right? The actual sequence, you know, what they should do, which drill is used when, you know, the starter bit, the R bit, the bottom bit, the taps, the 2 different taps that are used. All of these things, all the sequencing is done. This is all either a part of the training process that you do at the field level, or the training process for your training technicians, or just to make sure if you're a user or you're a contractor that has guidance over the guys doing this, you can make sure they're doing what they're supposed to be doing and doing it effectively and correctly, right? The drill through safety. This is a super important factor here, right? So we have, when I talk about having fail safes to keep from going to the atmosphere. This piece here is the actual injection fitting that you see left on most valves. Peter was asking about plugging. This one we use a cap, this one we use a plug. That's a pipe plug fitting that we go in there. There are others that have threads on the outside that you can pack. But this device here is called a high pressure packing gland. It's designed so when you're going to make this breakthrough in the process, you actually have a secondary packing gland that seals around the smooth portion of the drill. So when that breakthrough happens, you stop flow here. Now, when you bring that drill back and you clear to here, you're still up here, you turn this off, you never have any escape that atmosphere. So you can contain it, you can control it. This is the safety education process. This is the stuff that makes people nervous that we've now addressed effectively to say we can keep those things from happening by following these rules, using these tools. Okay. Breakdown of what that looks like. I like to show this. You got your injection valve. You got your packing would be here. You have your packing follower. There's your braided packing. You have your follower. You have your actual, what we call the gland. That's going to screw down. That's going to compress on here, which is going to bring the packing to radially expand IVW. Good afternoon. And then, of course, you still got to have your drill stop, right? Because you still only want to go so far into the packing when you're drilling into it and drilling through it. So no matter if you're using your starter bit, your finishing bit, or your breakthrough bit, you're going to still have that drill stop. And then once you've done all that, there's a process for injection. That's outlined in guidelines, right? You want to exercise the follower. You want to be able to, once you broke through, once you get gun pressure on your injectable, you're going to actually now loosen those valve gland flange bolts, and you're going to refill, reinstitute that stuffing box with now injectable packing, because you hit between the 3rd and 4th ring, they're going to hydraulically expand, and now that packing can be taken back to a like new condition. So when the technician walks away, if there's a leak in 6 months, 8 months, or 9 years, he can come back and retighten, go through that retightening process that he went through with packing if needed, to the point that if you bottom out the gland again through the 3-year tightening process, guess what he can come back and do now? Drill back in, clean out the injection valve, and go through the same process and start it. It's a continuum. Okay. Like I say, it usually takes a couple let's say 2 to 3 times of this compression and loosening to get that gland full, because initially you want to consolidate that packing just like you would do the traditional packing, but to the point that it's full, then there's an actual gauge on the gun. The Easy Pack Extreme Low E injectable, 3,600 to 4,200 PSI of gun pressure is what we're looking for. So once you've got it consolidated in there and you get that gauge on the gun, he sees it hold at 4,000 PSI, technician disconnects, walks away, and everything's like it's supposed to be. You got to understand the valves. Not every valve's suitable. OS and Y, outside stem and yoke. I'll show you some pictures here in a minute. 9 rising stem gate valves are not typically a candidate for drill and tap. Quarter turn valves, some of them are, some of them aren't. Orbit valves, there could be some, as I'll show you, there are some that are injectable, but they're not drillable. Okay, you can inject them because they're already set up for that. So you can use the advantages of the design where you don't even have to do the live drill. You can just come in and connect through a button head fitting, which this device would fit onto. This is a button head fitting, and this is the connector, and you can pump that. But here you go. So you got a globe valve, then you got a gate valve. This means OS and Y. Everything's outside stem and yoke. This valve would be drilled in this area. Obviously, that valve would be drilled in the same area. Those valves are obvious, basic, simple candidates. So here's a look at a butterfly valve. These could be drilled because they have the stuffing box capable of that. The trunnion ball valve has a packing gland. This one has a traditional packing gland. Again, you're looking at valves that would be candidates or capable of being drilled and tapped versus valves not typically capable. You're not going to drill this valve. There's no way, there's nowhere to drill it to get to the packing without drilling through the body, and then you got no control. Again, same concept here. Here, these valves typically use O-ring seals anyway, so you're not going to pump those, right? But here's an example of a valve that's not capable of being drilled, but is capable of being injected. This is an orbit valve, right? So already has the fitting right where you want it to be, right in the middle of the package. So you just come in and connect, you can pump it up, but this valve is designed as an injectable packing to be its breathable tightening process. It's designed that way. It's part of the feature, okay? Now, there are many valves that have these. Plug valves can be sealed with injection. A lot of plug valves can be sealed with injection. A lot of ball valves can be sealed with injection that already have these fittings set in place. And to give you an example, so here's a very new device that a friend of ours developed, Mike Dunn, actually the owner of JS Machining Valve. This is what he calls an environmental fitting. This is a live loaded injection fitting. So if you've got a valve such as this that's in an out of the way place that someone's not going to see all the time or not going to be able to check on all the time, you could pump that valve. That would also fill up this cartridge. Notice it has green. All right. As long as it's in the green, it's continually keeping a load of injectable on that valve. So the technician doesn't have to he can drive by and see. Now, when it goes here, guess what he has to do? That's reload it. It's that simple. So, I mean, these types of valves, these valves that are in tank farms or in, places that people aren't dealing with on a daily basis. I mean, we've had some conversations with Frank about this same concept with some valves that are just they're not daily visible to people.
What is that attached?
This just attaches to the button head fitting right here. This would attach just like this.
Oh, okay.
Just right with the fitting. This just slips on.
And there's in connections for it.
Well, there's 7 different designs. This is just a basic design. Well, I'm showing you because this is how we are continuing to advance this technology. We live load stuffing boxes on valves, right? I mean, if you go back and look at a valve like this, people put live load on these to try to help them seal long term and last longer. So why can't we do the same thing with the injection fitting? And so
Valves that have already been drilled and tapped, standard fitting on the end,
We have one.
those apparatuses will Actually, that's, you just gotta choose one that fits the vision.
Yeah, if you have one that has a traditional drill and tap leak sealing fitting, like you're used to, Frank, that one of your contractors puts on, we have one of these that connects and screws to that. Or if you have these valves that have the orbit style that already have the button head, which looks like this, we have these that just slip on. So it's a cool concept, right? It's a
Right,
cool
but
design.
you're not having to wait, it's not a technology that you gotta wait for your next drill to tap. to use.
That's right. Well, and look, as long as you're keeping that injection fitting full and flowing, it's just that, because what happens to packing, whether we're talking about this packing here, injectable packing, whatever, what happens to packing is the operation of that valve over time with loading consolidates. And to the point that it consolidates, that it has no more compression, that's when leaks start to occur, right? Other than mechanical failures where the stem gets cut or something, stem gets bent, but for just everyday use, if you just cycle this valve over and over and over and over, that packing's gonna just go. It's gonna squash down from consolidation. And leaks going to occur. That's what this is designed to do, is to keep that consolidation from occurring, because anytime it feels a relaxation in load, the springs are designed in here to force that. And that's why, and that's how this works. So the spring, it's live loaded. It's just gonna keep going, keep going, keep going to the point that it gets ready. Oh, well, we better get it. Gotta reject it.
Okay, so I got another one.
Okay.
So I have the existing drilling taps out in the field. Now buy the correct apparatus to go on there. I go over there and I put it on there and it goes to red. And I reload the valve like that and say, give me another one, but I'm calling a guy out.
So you could reload this yourself. This is designed to just hook on with the gun and reload this yourself. That's what this is, that's how this was designed, to reload, for you to be able to reload without a leak sealing finish.
Okay, cool. Yeah, so the old ones that have been there a year, if they start to leak, I might get a little bit out of it, but I just tighten that packing up. It's all the way gone, bring the gun with me, I'll reload it and leave it.
Yeah, what we're,
It's like a maintenance.
yeah, what we were working with, when I was working with Mike on this is to make the re-injection a maintenance event for the plant instead of a call out for a
Yeah.
contractor.
I think what you're doing. That action. That's all. That, and then
Well, let's change that a second. If he's got this, his packing plan is probably not going to engage downward because you're gonna be constantly loading. If you, when you continue to tighten, if you don't have something continually loading, you're gonna have to go down and re-inject and go down and re-inject. With this, you can keep your packing in a 70% tight range, let's just say, as long as you keep this loaded. Now, if you let this go down and you don't refill it, then you're gonna be tightening the packing, then you would have to go through the full process.
Yeah, I'm with you on that.
Okay, okay.
Yeah, so I'm saying like, I haven't had a leak yet, right? But I went out there and put it on there and I used half of it. That means I just avoided a potential leak.
Exactly.
And
You
now-
absolutely
now I'm in
avoided
the
that.
program, so I should sustain that, but obviously technicians are monitored quarterly, that can be put on a list to check the indicator.
That's right. That's the key right there, is that, just that drive-by, just go in there and look and make sure that that indicator's still in the green. And that they don't need to create that maintenance event, you know, instead of calling that contract. So. Right.
Message when that money goes back.
You know, I mean, ultimately, everything happens. Yeah. So,
I get other text messages.
so, we're getting near the end here of my time. I've got just a few more minutes, but we want to talk about what really has changed the thought process around the drill and tap is the fact that are there any ceiling contractors in the room? Okay. Because I don't want this to sound offensive, what I'm about to say, but it might be. For 60 years, people have been doing drilling taps and they've been pumping whatever they decided to pump into a valve without an actual control mechanism. Sorry, but Frank's here. Frank calls up a contractor and says, I got 17 drilling taps. They come out and they choose what they're pumping in there. Could be a Deacon product, which is very common, which is another company under the Jetlin Whitworth family of, yes, sir.
Could be a non-compatible.
Could be a completely non-compatible, could be a PTFE when you don't allow PTFE, and there could be mistakes being made because no one has had that control mechanism. So there's two things we're doing here. Number one, we created a product that, first of all, is graphite based. There's PTFE because there are some applications that require it, but the main product is graphite based. The main product has two levels of fiber because there are multiple levels of leak. There are high volume leaks that need more fiber. They're the standard, 127 parts per million, and your cap's 100, so you need something that just flows. And key factor here, no PTFE, that graphite product. It's a big factor. It's becoming bigger and bigger every day. The second thing is that we're getting ready to roll out this product is the ability to trace this product to know for sure you put Easy Pack Extreme in your valve. Your contractor put the right thing unless you buy it and give it to them. But if they come in, what they're pumping, because black product looks like black product to you, to everybody, right? But we're in the process of working with Edit. They have a product called Teddy Tags where we can actually blend into the process material that you can visually see sparkles to know it tags the product. So someone can't lie. They can't say they used Easy Pack Extreme and it'd be some other random black product that they decided to pump into your valve. So the key is suitability, right product, and making sure you're getting a low-end product because ultimately this product's passed testing. It's passed field testing, it's passed laboratory testing, and now it's passed years of service testing to the consent decree point that's why certain consent decrees have had these minor adjustments to allow for the use of low-E. If you remember, I mentioned this word being a bad word. Sealants are used for online repair of flanges, whether it be a heat exchanger, a pipe flange, a bonnet flange. Those sealants are designed to cure and to get to a hardening stage for a certain type of leak. If this technician goes out there and pumps one of these sealants into your valve that you want to still be able to operate, that you want to be able to use 2 years down the road, that valve's going to be killed. We call it killing the valve. That used to be a factor. You would kill the valve, you'd pump it full, and you didn't want it to move because you didn't care. But we want the valve to still be operable. We want the valve to still operate just like it did before we started. So it's not a sealant, it's an actual valve pack. Applications, they're using it everywhere, right? Okay, globe, choke valves, knife valves, plug valves, it's all there, right? So, handles high temperature. So the temperature range is not an issue. We know because we did testing, 624 testing. After we finished our field testing, we did 624 testing so that we could have a test to make it comparable to the other packings that are already being used for low emissions, whether it be a braided packing or a diaphragm packing. It's compatible with anything, which is what we're, however, we do also have the same version in a white version or PTFE version because there are some processes that may be considered clean, that they don't want a potential for contamination with a black product, so they're going to want a white product. We're going to always default to the black product because it is more wide-reaching in its suitability for sealing. Still 0 to 14 pH range is still, 1,000 degrees, temperature-wise, which you should never have an issue with. But the main thing about it is to know that there is a product out there, there is a product available, in that you can actually make a valve low leak by injecting now, not just replacing, repairing, or repacking. So, with that said, does anybody have any questions?
Thank you, Rodney. We'll open the floor for.
How do you, what is the back?
So we have, we've had several companies report back. We have in one location, not single location, but one company, we've done about 250 odd repairs in the past 3 years. 248 of those were successful. The other two were unsuccessful at the point of the drill and tap. So there's some factor other than, there's a factor in the valve that we can't see externally. Maybe some severe cut in the stem or something that we can't see. But for the most part, you're talking about 248 out of 250. And they've been operating for more than 2 years without a re-inject or whatever.
I have similar, I maybe natural gas processing, is that the space you're talking?
This particular, the largest user, single user is,
Natural gas.
but I will tell you this, because I've personally done the drill and taps. I've personally gone out and trained people. And recently at a facility in North Texas, we did a training and we were called out to do a series of 3 valves in a speciation that had been on their DOR list for a long period of time. When I'm saying a long period of time, I'm saying a long period of time. And they were hydrogen, high concentration of H2S, pentane, all the anes you can think of. When they sent me this, I'm like, there's really a process that has all of this in there? Well, it could have. That was what they said. It may not at any particular time, it may have everything in it. We drilled and tapped all of these. We physically did it and did all 3 in the same day. About 1 valve leaking, 1 was not. There were 6 valves. 1 was leaking, 1 was not. 1 was leaking, 1 was not. Valves from 1. Anyway, we plugged them. High pressure. These are high pressure valves. These are pressure seal bonnets. All kinds of stuff. They've been there for, what do we do, 9 months here? 9 months. I'm nervous. Anyway, being more and more refineries right now. The midstream play was the first big place that people were looking for because they see that as an advantage to them because some of these are in remote locations. Right, so.
I think the thing I heard is that some of the, they have large valve specialty. Hospital valves, just places, you know, a couple orders of magnitude, 1-inch gate valve, you know, or 1-inch quarter, you know, quarter turn valve, whatever you, there's smaller valves to protect it for price point is. It's drastically different. And I've heard this. I see.
We know.
But I think it's something that if you haven't been specifically out there, you don't have language. Something we've gone back and modified to allow the drill and tap to go to lower value in there and it knocks out. I use stop using the first. Knocks out 2 items.
Well, that's the thing is that people always look at it and they start doing cost calculation, cost analysis, and not here to talk about cost calculation. The reality of it is that we did some research with a customer, and because they were like, why would we drill and tap a 3/4 inch valve? Well, when they went back and looked at what it would actually cost them to replace that 3/4 inch valve, the valve may only cost them $50, the actual valve. The cost to replace it was $1,000. dollars in labor and all this stuff like that.
Go shut this world.
Anyway, thank y'all very much.
Thank you. Thank you.
Okay, Sam, your turn.
We'll give a couple of minutes for you to settle down.
It's a quick info.
It's a huge session. Yes.
Could you give me 2 minutes to stop the previous recording? Put it again, it's for the teams.
You want me to give you that? What do you want me to give you?
No, like just 2 minutes to stop the recording of the previous
Yes.
session.
Yeah. Thank you.
I just, I know. I deal with them.
I will never check with you again. That's it.
So it's recording? You will stop.
Yes, and I will begin it again.
There's a refund.